A slow change in the sky can signal a major shift in the air above you. Warm fronts form when a warm, lighter air mass advances toward a cooler, denser air mass near the ground. The warm air cannot simply shove the cold air away because cold air is heavier and tends to stay anchored at the surface. Instead, the warm air glides up and over it, like a ramp. Meteorologists call that process overrunning. As the warm air rises, air pressure around it decreases. The rising air expands and cools, a process called adiabatic cooling. If that air contains enough water vapor, cooling brings it to saturation. Then water vapor condenses into broad sheets of cloud, often far ahead of the surface front itself. This is why a warm front can change the weather gradually, sometimes over many hours. The first clue is often thin cirrus cloud high in the sky. Those clouds may thicken into cirrostratus, sometimes producing a pale halo around the sun or moon. As the front gets closer, the cloud deck lowers into altostratus, turning the sky grey. Finally, nimbostratus clouds arrive, bringing steady rain, drizzle, or snow. The rain is usually widespread and persistent rather than short and explosive. That difference comes from the shape of the front. A warm front is not a vertical wall, it is a very shallow boundary, often with a slope near 1 kilometer of rise for every 150 kilometers of distance, or about 0.6 miles for every 93 miles. Because the lift is gentle, clouds spread out in layers instead of building quickly into tall storm towers. Warm fronts are major parts of mid-latitude low-pressure systems. In the Norwegian cyclone model, the warm front marks the leading edge of the warm sector rotating around a central low. Upper-level winds, including the jet stream, help steer these systems and strengthen the temperature contrast that feeds them. As the front approaches, surface pressure often falls slowly. Winds may shift as the boundary passes, precipitation may ease, and temperatures usually rise as warmer air reaches the ground. Fog can also form when warm, humid air moves over a colder surface, reducing visibility. On weather maps, a warm front is drawn as a solid red line with red semicircles. The semicircles point in the direction the warm air is moving. Forecasters locate the front by tracking temperature changes, dew point changes, wind shifts, cloud patterns, and model data. Warm fronts are different from cold fronts because the advancing air mass is different. In a cold front, dense cold air acts like a wedge and forces warm air upward quickly. In a warm front, lighter warm air climbs gradually over retreating cold air. That is why cold fronts often bring sharper, more intense weather, while warm fronts usually bring slower, broader changes. Eventually, a faster cold front may catch the warm front and lift the warm sector completely off the ground, forming an occluded front. Later, as the temperature contrast weakens and the air masses mix, the boundary fades in a process called frontolysis. So the key idea is simple. Warm fronts form because lighter warm air rises over heavier cold air. That gentle rise creates layered clouds, long-lasting precipitation, pressure changes, and a steady transition into warmer conditions.